Welcome to GD Gyan. Don't forget to subscribe and click on the bell button.
Hello everyone, welcome to GD Gyan. Today we are going to discuss about DNS 101 and Route 53. So this could be our first networking session, and after that one more on the VPC, and that ends the entire AWS course here. Let's quickly look into the agenda, what we are going to cover. Just stay here for some time and let's go to the next slide. Different Route 53 components. So before we understand what is Route 53, how it works and everything, we need to understand some of the terminology that we are going through entire this discussion, right? So let's have this thing. IP address. We all familiar with that. Just remember there are two types of IP address. One is IPv4, which has 32-bit, and another is IPv6, 120-bit. So 6 blocks and 4 blocks. So just remember that IPv4 might have a time that it all get finished, so that's why the concept came of IPv6 to provide that unlimited number of IP address. TLD, top level domain, which is the last word of your domain name, which means like facebook.com, so .com, .edu, .net, all this example you see it, right? So that is called top level domain. And the second word which represents second level domain, which is like gov.uk, com.au, all those things. So we understand IP address, we understand TLD. Now let's look into the domain register. So anywhere we register our IP address, our domain name, for example gdgyan.com, so all those providers are called domain register, which is Amazon itself is a domain register. Apart from that, GoDaddy and other there are a lot of other providers are there, and they are regulated by an authority called ICANN. So they ensure that your domain name is being unique across the globe, currently across the globe. Yeah, NS record or name server record. So whenever you get a domain being registered into domain register through your domain register like GoDaddy or Amazon, you would be getting definitely IP address and the domain name. For example, my case, if it is www.gdgyan.com and the IP address, along with that you'd be getting name server record, which looks like this one, ns1.aws.com, ns2.aws.com, which ensures that for example, if you have one domain, you would be getting 4 to 6 name server, which ensures that one of the name server should be running, kind of a fault tolerance method. SOA, start of authority, which stores all your information, your name, your TTL information, your email address, IP address, all the server name, all the details. That SOA saves those details. A record. So gdgyan.com is having IP address, so that is called address record or A record. So one website have a IP address, that mapping or that record is called A record. So every website has a record. That's clear, right? Yeah. C name or canonical name, which is like I have a website called gdgyan.com, which even been called from mobile that m.gdgam.com, mobile.gdgam.com. So all the alias that I have for my website which points to single IP address, those alias being called as canonical. So you can understand that it's the different name but points to the same IP address is the C name. Alias, there is a different term called alias which looks like same as C name, which also provides your DNS, which you're getting from your Elastic Load Balancer, CloudFront distributor, or S3 bucket name, that DNS name, to a domain name, right? So that mapping is called alias name. So both look like same, C name and alias name, but alias name can be naked and C name cannot be naked. So that's the difference that we can remember for now. Now let's understand what is the public IP and private IP and how actual internet works. Let's have a look. You have a router which you are got from Alliance Broadband or Megbal or any of the internet provider, that is your ISP, internet service provider, or BSNL Jio. So they gave a wire network to you, or wireless, however it is. So that router, you have your iPhone, you have your smartphone, iPad, everything being connected to the router. So each of the device getting connected to the router and being access the internet, they have a private IP. So that IP talks to the router. So whenever you, your sister, your mom, dad sends a request to the router, that private IP goes to the router. It has one public IP assigned which talks to the ISP, and ISP reaches to the internet. And when they get the response back from the internet, ISP return back to the router IP, and router return back to your uh, computer, iPad or smartphone, from the private IP it received the request. So we understood that private IP and public IP concept. This concept mainly for that to save the IP address across the globe, and secondly, do not have duplicate of this identities. Now let's understand, we all gone through the name server, name record server, SOA, and top level domain, right? So now let's understand what happens. So suppose I have placed a request for www.gdgyan.com. Now that website has a tld.com, so it goes to the tld register. It checks, okay, it's .com. Then the tld register sends that to name server record, and it gets the name server. So is it ns1.aws.com, ns2.aws.com, or ns3.aws.com? We mentioned that, right, in previous slide. So based upon that ns record, it goes to the SOA where it finds their address record, a record, the IP address, right, or the CNAME record. So suppose I'm searching m.gdgyan.com, so that also points to gdgyan.com and points to one IP address. So based upon our search, we get the IP address. So I hope this slide remained clear how the private public and IP address concept came, how it talks to the ISP to the internet, and how the resolve the top level domain to the name server to the SOA record, and where it gets the IP address. So that is the SOA record who actually sends the DNS mapping and gives you the IP record. Let's move to the next slide then. So let's come to the basic topic, what is route 53. So the DNS, right, the DNS port number is on 53. So the service AWS call as a route 53. So route 53 Amazon AWS DNS service, domain name service, where you can have your routing policy. So suppose you have one EC2 instance which has a website where you save your images. Now that EC2 instance has an endpoint being created, and you want entire world to access that service. So what you need? You need a website. So that website needs to be registered. So where you can register? You can register to any of the website domain register authority. GoDaddy or Amazon itself is that kind of authority. So if you have if you're trying for Azure, if you're trying for GCP, there you cannot register your domain name. For that you have to choose any of this domain name register, which is AWS, GoDaddy, and there are so many. So once you get your domain name and IP address, then you access those EC2 instance, those VMs, those server, and external wall also access that. So that service being provided by the route 53. So this is called domain name service, and on an advantage, AWS has the authority to give you that IP address. It act as a domain register as well. So just check how it happens. Like you provide your details, register details to the AWS, it being verified to the ICANN, this authority. They validate that it's unique. They do check other restriction and everything, and they return back to you the IP address. It takes some time based upon the TLD you are selecting. Let's go to the next slide then. So now we are going to discuss what are the different routing policy or the routing policy AWS provide, right? So the first one is a simple routing. So you have one domain, and you have multiple group of users. So you have two of the boxes being created, two of the IP address you being set up for that, and you don't want it to make it very complex. You want it simple, the name at suggest. So any person accessing that randomly, they'll go to this first block, or the second one accessing that randomly will go to the second block. It's not based upon any rule, any policy, or any condition. It randomly goes to the first IP address or second IP address. So suppose I am typing gdgyan.com, so whether it's taking me to that .1 or .2, it depends on completely on the random. There is no rule. So it's called simple routing. You're not putting any condition. Anywhere it has two IP address being configured, it goes to any of those. Now one more concept came here, multi-value routing, which is same as simple routing, only thing it has associated with a health check. So in case the simple routing, it's going, suppose I hit for the first time, it went to here, second time also it went to here, third time it went to here, right? But on a certain node, this one is down, this link is not working, this server is down, then we can set up that health check on simple routing. In simple routing, there is no way to we can set up health check, but in multi-value routing, multi-value answer routing, we can have a health check. So that's the only difference. So we understand the simple routing. We are going back to the next one, which is failover routing. As the name suggests, it's act as active passive. Whenever the active node is working fine, all the traffic for gdgyan.com will go to this region or this instance, and whenever this instance is not working, it will go to the passive region. So it's just failover. You understand the name suggests, right? And there is one called latency base. So suppose I am in India and I have two, now I have, suppose we have two zone here, two region here, one in Mumbai and another is for example Chennai, and I am located somewhere in between, like called Hyderabad. So for me, the latency wise, if Mumbai is the giving me the lowest latency, my network will go to Mumbai. If Chennai is giving me the lowest latency, it will go to Chennai. So based upon latency at that particular time, my traffic will go to that particular IP address or that particular instance, though I'm accessing the same URL. For example, I'm accessing facebook.com and I'm out of Hyderabad or some part of that Andhra Pradesh, right? So that's how it works. Based upon the latency, whichever gives you the lowest latency, your traffic goes to that server. Anyway, all the server has the same information, so there is no doubt about it. That's how it is being created. Let's go to the other one, which is called geolocation routing. So understand that thing. I'm in India, my traffic will go to the region which is there in India. I'm in Europe, my traffic will go to based upon my region. It's not, the difference between latency and geolocation is that geolocation based upon your location, latency based upon the latency. It might happen that you are into one country, one side of the country, and your latency, you suppose you are into Europe and your latency in any of the US region is lower than any of the European other region, right? So your traffic will go to US part if you are using latency based routing. For geolocation, it will always follow the location. And how it happens, because some of the time, right, your website contains regional information, language, if it is a news website, if it is some of the political website, those things strictly holds the location specific information. So there we need geolocation routing or the routing. Weighted routing, at the name suggests, so I have two VMs being configured. I want 50% of the distribution. If one server is being 50% loaded, then traffic will go to the second one. So based upon my configuration, my application architecture, I would be deciding that where the traffic would be going. So as the name suggests, it's weighted routing. Geo proximity routing, this is very complex kind of a routing method. It will never come into your solution architect associate, neither into professional exam. Moreover, it comes into the networking exam. So just understand this thing. It is not only your location, so you can have access based upon your location, I mean your user location and your resource location. So based upon that, you can decide your region, and that specification value called bias, I mentioned here bias, and you can expand, you can shrink your bias. Based upon that, your geographic region will vary. So I have given three picture here from AWS website. So you can see, right, that 2 is one of the region. So for some of the resource it is wider and some of the resource is very shrink. So it's based upon your user and the resource that you wanted to access to. It's called geo proximity. It's very complex, and definitely understand it is not going to come into your solution architect exam. So that is it, guys. Here we cover this entire slide. Thank you.
Please like, subscribe, share. Thanks for watching.